All right, so I want to do number 7 in 2.1, which apparently involves, at best, stupid integration, possibly really hard integration.
It's not too bad.
Oh, you guys are like, it's not too bad. These guys are like, oh, God. Someone forgot a part of their integration table. All right, so first things first, I have xy prime plus 1 plus 1 over log x times y equals 0. So, what kind of beast is this? First order linear homogeneous differential equation. So, what do you do?
Do the form.
Yeah, sure. You can do the homogeneous form, but first you need to
Get it in the right.
yeah, you need to get that x away from the y prime. So first things first, you need to multiply everything through by 1 over x. Which, it should be noted, probably causes some problems with solutions, right?
But that would be the trivial solution anyway.
When x is 0? No, when y is 0 is the trivial solution. X is 0 might punch a hole in my interval, right? But the log of x isn't defined at 0 anyway. You guys see that? Sweet. I don't have any problems with my intervals anyway.
You said it's not defined as 0. I thought the natural log of 0 was 1.
Natural one.
That's what it is.
Had me for a second there. Natural log looks like this one. It's got a problem.
Wait, so did we say that 0 is okay?
No, 0 is a problem anyway.
Okay, it's a double.
So I'm making a problem at 0, right? By multiplying everything through by 1 over x, really dividing everything by x. I'm causing a problem at 0 potentially. Except that this thing's already dorked at 0, so it's not like you added anything to it. So I think I got y prime plus 1 over x plus 1 over x log x times y is 0. Okay, so to get my form, I should be considering negative the integral of which thing?
Stuff in parentheses. Yeah.
Stuff in the parentheses. 1 over x plus 1 over x log x. dx. Okay, now the reason I broke this out a little different than I use, normally this would have a big ass E right here, yeah? Right? And like some kind of little like Y. But the reason I broke it out this way is that you guys were worried about the integration, right? Okay, so write it off in the margin, scribble with it a little bit, see if you can get it to work with it before you cram it into all this other stuff, right? Like, this is one of those how do you eat an elephant thing. Jeff Tolhurst loves this statement. You know how you eat an elephant?
Small pieces.
Yeah. One bite at a time, man. Same way you eat anything. It just takes a while. Same thing here, right? Like, take one little bit at a time. Really definitely the same thing for computer programming. How do you do this? Like, how shit?
Why did we distribute the 1 over x into the parentheses?
I don't know. Because it
easier.
did. Would it have made it better if I hadn't?
I don't know.
It would have been parts.
I was just wondering if it made it any easier to do it the other way.
Yeah, I like museums better than parts. So.
I'd probably try both. Like, I think this is going to go okay, so I'm going to try this.
Okay.
If it didn't work, go back and undistribute and try it with it undistributed. Maybe it'll work better. Like sometimes the algebraic form is my only problem, right? So, all right. So I'm going to split this up into minus the integral of 1 over x dx minus the integral of 1 over x log x dx. Okay, good? Okay, so what did I use to do that? Like,
Properties of integrals, right?
Yeah, that's linearity of squiggly symbols. Right? Linearity of the D-eater. Really, it's just algebra with the D-eater, right? You just distribute it in there. Crazy.
Yeah.
Okay. So what's the integral of 1 over x?
Natural.
Absolute value.
Okay. Negative natural log absolute value of x, right? Okay. Minus.
That works out for you so nicely.
Minus.
Okay, let me write it up here.
Yeah.
You guys think I've got a u sub on hand? What's your u?
Natural log, yeah.
Let u be natural log of x? Oh wait, just for fun, I'm going to do win substitution. That's not a win. That's a win. I found a fun video that had old letters that are antiquated, no longer used. Apparently win was a contender for being a W. Like at some point there were 2 U's written next to each other that had a sound, right? Eventually they got shoved together and formed into that character you call a W. A win is the other contender for that character. Like this is like almost a letter in the alphabet.
Was it like Webster back then was dealing with this, or was it?
No,
I
this
think
was
we're
like
talking like Chaucer.
pre-typesetting.
Chaucer.
Yeah.
So if I was wind, what did P look like?
What? They're probably the same.
They look kind of like this, but a little different.
Oh, really got rid of it.
Yeah, I mean, it's not a great letter. So anyway, if win is log of x, what's d win?
Oh, and,
Yeah, so it's- One of those.
1 over x dx. Okay, so then I think I've got minus natural log of the absolute value of x minus the integral of,
well, if you just do it, it's natural log of natural log of x.
it's not, sorry, it's not in my muscle memory yet. 1 over win, do you win?
Is it like half of a heart that's been sliced with a...
Sure, I have no idea. I'm just making up symbols now. That whole thing I told you about this being a letter, it's just a lie. No, it really was a W. All right, so what do I get? I get the natural log, right?
Yeah.
Of the stuff, but the stuff was already a natural log. So I think I got minus natural log of the absolute value of x minus the natural log of the absolute value of natural log of x.
That's...
Yeah.
Careful with that.
See that,
Oh, yeah.
Natural log is sometimes negative. Yeah, a lot of the time. Like all the numbers between 0 and 1, not including 0 or 1. And there's a lot of numbers in it. There are. Tons. Okay, so what was this thing? That's my,
Something.
That's everything that goes above the E.
yeah, that's everything that goes above the E, right? So your solution should look like y of x is a e to the natural log of 1 over the absolute value of x. So I sucked that negative 1 up as a power, right? And then I also got a plus natural log of 1 over natural log of x, the absolute value. Because I sucked the other one up too. Because slick, man. Because that's slick. That's why. And then you can rewrite this as a.
Can you not?
Have you seen a clever thing?
Can you get rid of the front natural log on both of those? Just make 1 over x plus 1 over natural log of x.
Yeah.
So close.
Well, there's a negative, there would be a negative sign up there, right?
Yeah.
Or try to get rid of that. That becomes an
Does it come
exponent.
back?
So what you need is an exponent rule, right? Because this inverse function to natural log can only get at one of those at a time. Is that? But they're added together.
Why don't you factor out the natural log then? Just take 1 out.
Because natural log's not multiplied in there, right? It's a function done to that stuff.
You combine them.
You guys see that? But what you can do is hit it with an exponent rule. You can say that if you have e to some stuff plus e to, or plus some other stuff, that's e to the first stuff times e to the second stuff.
Is that second sub?
That's like x to the n plus m is x to the n times x to the m, right? Like when there's two bases and different exponents, you add the exponents, right? Like x times x is x squared, because 1 plus 1 is 2.
Yeah.
Okay, so then you can cancel the e's and the logs. And so what you get is a 1 over absolute value of x from that guy times 1 over the natural log of x in absolute value. So all told, you get a over x log x, and those are all in absolute values.
Can we combine those?
Can you take the 1x absolute value off and incorporate it into constant?
Oh, this guy?
Yeah. And put it into your A?
Yeah.
Yeah, I probably would just drop it all together though. The reason you could drop it all together is that natural log of x isn't even defined for negative x's, right? So those wouldn't make any sense anyways. You don't have to bother to absorb it in the constant because it's just not needed at all. So you really could drop those. But you should keep the one around the natural log of x because it could actually be negative. You might have a reasonable case for absorbing that into the constant, and I would be okay with you doing that. You guys cool with this? All right. Did they give? Oh, and they gave me an initial value. So worrying about this constant might be overkill anyway. Okay. What is your constant? What is your initial value problem? You need to plug in e, right? Okay, so y of e should be a over e times log of e. Log of e, to the best of my recollection, is good, a number, probably 1. Really, it's definitely 1 because this is asking what power of e is e. E is the first power of e. So you got a over e, and what is that also supposed to be? That's also supposed to be 1, which kind of seems to imply that a is e, right? And so your solution should be y of x is
E divided by x times absolute value of natural log of x.
e divided by x log x. In absolute values. Yeah. And then where is this solution valid?
At y is e, or if you, yeah.
Good, it's definitely valid at y equals e because I calibrated it that way, right?
X
What
should
is
be-
the best possible interval on which I could hope for a solution right now?
X should be bigger than 0.
Maybe from 0 to infinity? Like that's a decent guess, right? Like why 0 to infinity?
Oh, oh yeah.
Because
We know we can have a negative for the natural log.
Yeah, because the natural log part of it definitely wouldn't work outside of 0 to positive infinity, right? Okay, but there's one more complaint, which is, what are you dividing by right here? You're dividing by the natural log of x. So not only do you need the natural log of x to work, you also need to not divide by 0 there, right? So like, this is my thought. I'm starting with like, all the real numbers could be a place where this is valid. Then I definitely know that from 0 on down, this is broke. That was because it doesn't fit in the natural log function. Then, where am I worried about dividing by 0? When x is 1, I'm worried about dividing by 0. So there's another probably hole punched in this thing at 1. Where does e live? After 1, right? And so my natural log of x is definitely going to be positive after that. And the best I could hope for an interval is from 1 to infinity, not including 1. And at this point, that's just a best hope. You guys cool with that? I don't have an existence and uniqueness theorem yet, so that's my best hope. Cool?
Just, why don't we include 0 to 1?
Yeah, I was about to.
Yeah, so why isn't that working? Well, because I evaluated this thing at E, right?
Mhm.
So I calibrated it on this side. So I don't know what the heck's going on over there. You guys see that? Like, this solution specifically works on the right-hand side of 1. I don't know what it does on the other side. It could do anything. Really, there's an asymptote discontinuity there, right? So the constants could be different.
Oh, I see.
You guys see that? Like, your choice of constant is kind of up to the interval on which you're continuous. This thing's not continuous across that break. So knowing something about the calibration, my initial value on this side, tells me about the constant over here. I don't know what's going on between 0 and 1, because I didn't calibrate it there. You guys see that? Kind of help?
Now, if it was before you distributed the x from the originals there, and you made 1 over x natural log of x, when I put just 1 over natural log of x by itself actually, I guess you'd have to distribute it anyway, so never mind.
Yeah. So the reason you were running into integration problems was that they had very carefully constructed this so that the p was going to be an integrable function. And when you missed this part,
Yeah.
right, you got a p that wasn't integrable, and it seemed like it wasn't solving. But the reason it wasn't solving was because you hadn't quite got it to the form before you selected your p. Another thing you could have done is you could have subtracted this to that side and then divided by a bunch of garbage to separate. Right? So if it seems like you're having trouble with the integration from the p thing, like that's just a form, right? Like maybe you misremembered the formula, or maybe you're just having an off day. If it's homogeneous, like try to separate the variables. It might work. Cool? Like sometimes just a different approach is all you need.